Okay, here we go. Oh, we're gonna finish early then. Well, this class, we get all the way to the end. So it looks like the quiz is gonna be on Thursday. Number 2, isn't that like the one I showed you yesterday? Oh boy. Okay, which one you want to do, 2A or B? I'm not going to do both. They're both the same except they're B. Okay, it says, write the equation of this quartic polynomial. What does quartic mean? Now, it's important, you got to look at that window now, because the window is going to tell you the x and y intercepts and things like that. So what are the x-intercepts? Looks like -1, 1, and 2. These are the x-intercepts, and it goes like this. Cha-ching! This is like the test. I'm going to give you a graph. You have to write the equation. And then what's the y-intercept over here? What does it look like? So -4 to 6, 1, 2, 3. So 0, 3. Okay, I think we have all the information we need. So the first thing you do is write y equal. Okay, the x-intercept is -1 here. So what do I write? X plus 1, and then x minus 1, and then x minus 2. But since the thing bounces off over here, then what? You got to have a square on the x plus 1, and there's a number in the front. How do I figure out what this number is? You plug in the point, the y-intercept. Well, sometimes it's not always the y-intercept. So if I plug in 0 for x and 3 for y, you get 3 equals a times 1 times -1 times -2. Therefore, a equals 3 halves. Therefore, the equation of this quartic polynomial is equal to y equals 3 halves x plus 1 squared, x minus 1, x minus 2. Should I box it and leave it like this, or should I take the gamble and multiply it out? Is he know any in this class? Okay, and then number 6. Oh, very good. Is this class good? I think we'll be seeing a word problem on Thursday's quiz where you have to solve it using your graphic calculator. Now, come on! You have a box. The length is 4, the width is 2, the height is 1. What's the volume of this box? 8. Okay, now it says, if each dimension of this box is augmented by x, what the heck does that mean, augmented? Increased by, isn't that on your list for SAT? So if you increase each dimension by x, it becomes 2 plus x, 4 plus x, 1 plus x. It says the volume of the box gets doubled. So what's the volume of this box? 2 plus x times 4 plus x times 1 plus x. And we want that volume to be equal to, double this volume, right, which is 16. And how do you solve any equation on your calculator? I taught you this last chapter. Make one side 0 and graph it. So on your calculator, you go y1 equals 2 plus x. See, once you have the equation on your paper, you just take your calculator. You guys can make one side 0 in your head, right? Bring the 16 over. Right? Graph that on your calculator. Wherever the thing crosses the x-axis, that's your answer. So, if you graph this on your calculator, I'm thinking it's gonna, I don't know, look something like this maybe. Whoa! That's what I'm guessing, but I don't know for sure. Who graphed it? Zhang? Yoshino? What? Nobody. Not one person graphed it! Time. Beyond. Yoka? Did the graph look something like that? Yeah. Let me see. Yeah, it did. So this is your answer right here. So you remember how to calculate the 0? You guys better know how to do this for Thursday's quiz. Maybe 2 problems you're going to use your calculator on Thursday's quiz. You calculate the 0. And so if you have a TI, you calculate the 0. Left bound, right bound, guess, ka-ting. if you have a, what's the other one called? The prism, you just draw the graph, press G solve, 0, boom. Thing spits out the answer. So you guys have it? No, I just write the answer on the bottom.
For the prism, can you use the equation?
Is an equation solver?
Yeah.
You know how to use it?
I think so.
Okay, let me ask you this. What if an equation has like 4 solutions? Does it give all 4 solutions?
Yeah.
Or does it give just one?
It gives all of them.
You sure?
Yes.
I don't know if that calculator is that powerful, that's why. No, you gotta be careful, you know, because yes, even a TI has a solver, but it only gives you one solution. So if there's like lots of solutions, how do you know you got the right one? You know what I'm talking about? That's why I think it's better if you graph it, because then you can see how many solutions there are. Anyway, by the way, what kind of polynomial is this? What's the degree of this equation? It's degree 3. So didn't you guys learn something last year, fundamental theorem of algebra, that if you have a polynomial of degree 3, there should be 3 roots? There should be 3 answers, right? You guys learned that last year, right? A polynomial of degree n will have n roots. So this equation is supposed to have 3 answers, but the thing only crossed the x-axis once, so I get 1 answer. What happened to the other 2? They're imaginary, that's right. Well, they're either imaginary, or maybe you didn't graph enough. Maybe the graph looks like this. Further to the left, right? You just didn't look far enough. So there's all kinds of possibilities. But is it possible for these to be the answers? What if it did cross the x-axis here and here? Would those be answers? No, because you're augmenting it by x. X is a positive number. Oh boy. So are you sure that's all the questions you have? Okay, good, very good. Okay. Okay, now tonight's homework, if you look at we're going to finish early. You have 7 word problems to do. All of them you got to use graphic calculator too. I will do one of them for you, so you actually only have 6 to do. So I'm going to do number. I don't want to do the easy one or the most difficult one. I'm going to do a medium one. So I'm going to pick number 5. A cylinder is inscribed in a sphere of radius 5. Can you imagine that? We have a sphere of radius 5, and then I'm going to inscribe a cylinder inside it like this. You guys know what a right circular cylinder is, right? Okay, part A. Write the volume of the cylinder as a function of x. Okay, now before we go any further, can I assume everybody here knows the volumes and surface areas of cylinders, cones, and spheres? Or should I write it on the board this one time and then we never write it again? Okay, here we go. Volume, surface area. So first we start with cylinder. If you have a cylinder of radius r and height h, what is the volume? That's on the SAT, right? This is in the directions. What is it? Okay, let's pretend we don't even know that. What did we learn in geometry? When you have a prism, isn't the volume going to be the area of the base times the height? What's a prism? What's the area of the base? What shape is that? It's a circle. It's a circle. What's the area of a circle? Pi r squared times the height. Hey, that's the thing on the SAT, Mr. Park. Duh. And then surface area. Now, I'm sure your geometry teacher showed you this, right? You have a cylinder. Oh, you unfold it. It's a rectangle, right? So what's the area of a rectangle? Isn't it just length times width? But isn't the length simply the circumference of the circle? So what's the circumference of a circle? 2 pi r times the width, which is what? The height. There you go. Surface area. Move on to cone. What if you have a cone, radius r, height h? Oh, nobody's going to ask the question that period 6 asked. Period 6 asked, well, what about the bottom and the top? Nobody's gonna ask about that. Okay.
Well,
Oh, what about it? Yeah, what about it? Exactly. What about it? This is a cylinder, people. This is a cylinder. A cylinder does not have a top and a bottom. This is the cylinder. If it had a top and a bottom, you know what it's called? A can. No, it's called a can. Just like a cone doesn't include the bottom part there. It's just like the shave ice cup part. You know what I'm talking about? Okay, what's the volume of a cone? What did we learn in geometry? Let's go back to geometry, 9th grade. When you have a pyramid, isn't the volume of a pyramid going to be 1/3 the area of the base times the height? That was drilled into you. So 1/3 the area of the base, which is a circle, times the height. Oh, Mr. Park, then it's just simply 1/3 of that then. No. Didn't your geometry teacher show you this? Your geometry teacher got the shave ice cup, filled it up 3 times with rice, and pours it into this, and it comes out exactly. It takes 3 of these to fill up that, if you have the same radius and the same height. Mrs. Nira used rice. Mr. Masunaga uses the urine. Who had Mr. Masunaga? Did he use urine? He did, right? The yellow water. The urine. Someone said, what's urine? It's yellow water. I don't know, it might have been Mountain Dew, I don't know, but doesn't he do that? Yes. Oh, now what about the surface area, which doesn't include the bottom? What's the surface area? I'll just tell you, same time, pi r L. What's L? L is the slant height. All of these things are in the inside cover of your Algebra 2 book. It's like all there. And then finally, sphere. If you have a sphere of radius r, what is the volume going to be? 4/3 pi r cubed. Does that sound familiar? And the surface area is 4 pi r squared. Okay, from this day forward, we do not speak of this. This is just assumed to be in your memory. That's why you take geometry before you go to calculus, people. Okay, have we got to that? Anyway, you can always go back to the video and look. Why would you do that when it's in the inside cover of your Algebra 2 book? How about just Google it? I'll tell you what, in pretty much any math book from geometry upward, if you just look in the appendix or the inside cover, it's all there. Okay, now going back to this problem, I forgot this problem. X represents the distance between the center of the sphere and the base of the cylinder. This is a crooked picture, too bad. Okay, that's X. Write the volume of the cylinder as a function of X. So we need to write the volume as a function of X. That's part A. So first thing you gotta know, what is the formula for volume of a cylinder? Pi times the radius squared times the height. Except we have to write it in terms of X. Now I know last year you guys did a lot of these problems. That's why we're doing it again this year, so that when you finally go to calculus next year, you have 2 years of experience. You're going to see these exact same problems next year in calculus, except we're going to use a graphing calculator to solve the problem. Next year you're going to use calculus. Okay, so look at this. The height is easy. What's the height of the cylinder, if that's X? Yeah, it's 2x. That's easy. The height is 2x. But what about the radius, Mr. Park? How do I figure out this radius right there? I don't know. Well, the only information you're given is that the radius of the sphere is 5. How should I draw in the radius to help me solve this problem? Straight to the bottom. Straight to the top. To the side. Coming out this way. Come on! Well, you draw it like this, because then, oh look, a right triangle is formed. Now, yes or no, do you have the skill? If 2 out of the 3 sides of a right triangle are given, can you just look at it and go, okay, this side is going to be the square root of 25 minus x squared? Do you have that skill? Or do you have to use the box method? What's the box method? Okay, look. What if you have a right triangle? What if this side is 5 and this side is x? How do you figure out this box? You use the Pythagorean theorem. Box squared plus x squared equals 5 squared. Box squared equals 25 minus x squared. Box equals square root of 25 minus x squared. So what do? Do you go straight or do you use the box? Okay, What? No, that's not correct. Okay, I'm telling you right now, when you go to, by the time you get to calculus, you cannot be drawing boxes. I guess if you go to AB, you can, but in BC calculus, you've got no time for a box. Okay, let's do another one. What if this is x and this is 4? How do you label this? Quick, without the box. Square root of x squared plus 4. What do you mean, no? Okay, let's do the box. Put the box, this is box. X squared, here, Pythagorean theorem. Box squared equals x squared plus 4 squared. Box equals square root of x squared. Oh, that's wrong. It's 16. I wonder if it's wrong. Okay, anyway. We got that on video too. Anyway, so the radius is the square root of 25 minus x squared. And there, everything's all x is done. Simplify. How do you simplify this? When you square a radical, no more radicals, so your final answer is 2 pi x times 25 minus x squared. Hey, Mr. Park, it's a polynomial. Duh, that's what we're studying now. Just like last chapter, all the word problems we had, didn't they come onto like quadratic? Now the word problems are going to come on cubic. In fact, every single one of these problems is going to get a cubic polynomial function, okay? Now let's do part B. Part B. Find the value of x that maximizes the volume of the cylinder. See, now the volume is a function, it's a cubic. So if I were to graph this, would the graph look like this or like this? Is it A or B? Which would it look like, A or B? It's B because the leading coefficient is negative, right? Wouldn't the first term be negative? So it's going to look like this. Right, so isn't there a place where you have a maximum? Now, is this the absolute maximum though? Because this graph keeps going up like that. No, but this is a local maximum, right? But see, this is a physical problem. This problem has a domain. In fact, if I were to ask you what is the domain of this problem, what would you tell me? X has to be between... Okay, x represents a length. Do you think a length can be 0 or negative? No, so x has to be bigger than 0, but smaller than 5. How come? Why in this problem can't x be bigger than 5? Because in a right triangle, isn't the hypotenuse always the longest side? So how can x be bigger than 5? Or you can just think of it, look at this. If x is bigger than 5, you get a negative in the radical. So this problem only makes sense if x is between 0 and 5. So that means we're not looking at the whole graph, we're just looking at like a part of the graph here. So if you look at just the part of the graph here, ooh, this is the absolute maximum. See, because when you inscribe a cylinder inside a sphere, how many ways can you do it? See, some of you go, what? I don't get it. Okay, what if I ask you, okay, here's a sphere, put a cylinder in it. Some of you might do something like this, right? You make a long, thin one, like a straw, right? Pixie stick. Oh, now I know. I don't know straw, I'm a pixie stick. Or you can make it wide and the height is very tiny, like a poker chip. Quarter. Something you can relate to. I don't know. Or you can put it like something like that, right? But which one of these has the biggest volume? Do you think it's going to be the long thin one or the short wide one? No, it's probably going to be something like that, yeah? So now we have to figure out how can I design this cylinder so that the volume is as large as possible. So what you do is you write a function for it, and then you graph it, and then right there, oh, there's maximum volume right there. Now, last chapter, how did we calculate the maximum? When you have a quadratic equation, quadratic function, what did we do? We find the vertex, negative b over 2a. Is that going to work anymore? No, because when you have a cubic function or higher degree, you can't use negative b over 2a. We use our graphing calculator. So take out your calculator. All of these problems, you got to use your calculator. That's what's called decimals, man. Okay, so the first thing you got to do is punch in the function. So y1 equals 2 pi x times 25 minus x squared. Or should I multiply that out? Don't you dare multiply it out. Your calculator doesn't care what form you put it in the easiest one for you. And then just press the graph button and hopefully I see something. No, you set the window. You set the window. This is probably the hardest part for some of you. Just want to press a button and you want the graph to be there, but you have to set the window. Okay, now what should I make x min and x max in this problem? X represents this length right here. I kind of told you already. You look at the domain of the problem. What's the domain? 0 to 5. That's what x min and x max should be, 0 and 5. Now, what about y min and y max? Well, what does y represent? No, right here. What does y represent? No, the volume. Is it possible to have negative volume? Do you really have to think about that? No, so you should make y min 0. Now, this is the hardest part. You have to figure out what should you make y max so that you can see this hump on your screen. Because if you don't see the hump, how are you going to calculate the maximum? So this one way is you can just guess. Start with 10. If you don't see anything, then try 100, then try 1,000, then 10,000, and keep increasing it by factors of 10. Or you can be smart, like this. What is the volume of this entire sphere? What's the formula for volume of a sphere? 4/3 pi times the radius cubed. What is 5 cubed? Okay, I'll just write 5 cubed for your viewing pleasure. And isn't pi about 3? It's about 3, right? So 125 times 4 is about 500. So the volume of this entire sphere is about 500 cubic units. And since the cylinder is inside there, doesn't the volume of the cylinder have to be smaller than that? So wouldn't it make sense to make y max 500? Because you know the answer got to be smaller than 500, right? Or would you rather have just the guess and check method? Try 10. If I don't see anything, then 100. And if I don't see anything, just try 1,000. That works too, whatever. So anyway, whatever you did, you guys see the hump over here? Okay, now do you guys remember how to calculate the maximum from yesterday? So if those of you with the TI, you go second, calculate, maximum. Left bound, move the cursor somewhere to the left, press enter. Move the cursor somewhere to the right, press enter. When it says guess, don't guess, just press enter again, and a calculator will give you the coordinates of the maximum point corrected 5 decimal places. If you have the prism, just draw the graph, press G solve, maximum, boom, the thing just spits out the answer. Anyway, what is it? Let me see if I remember the other class. 2.887 302.300. Is that right? Oh, yeah, that's a good memory. I haven't lost the touch. What?
Are you playing the game?
What game?
Or were you like, I don't know, pretend like you're calculating?
No, I'm not calculating. I'm just trying to remember what I wrote on the board last class period.
Or is that on your paper? Like playing the game, like calculating something.
I have, is there anything written on this page? That's the second meanest thing anybody ever said to me.
What was the first?
What?
What was the first?
I do.
Oh.
Some of you could think about that. You know when you get married, you can say, I do. Do you take this woman to be, whatever. Go home and think about it. That's the second meanest thing anybody ever said to me, I do. If I have to explain every joke, I heard somebody going, what? What's talking about? Go home and ask your parents then. Okay, now once you calculate this maximum point here, the coordinates, now answer the question. What does the question say? Find the value of x that maximizes the volume of the cylinder, duh, 2.887. But then on my quiz, I might ask you, what is the radius and the height of that will give you a maximum volume? So what would you say? What is the radius? What is the maximum radius and height? Once you figure out what x is, how do you figure out the radius? You gotta plug this number into here, because that's the radius. And don't just plug in 2.887. Why not? Why can't I just plug in 2.887 into there? Because you might get a rounding error in the last decimal place. Whenever you use a number in another computation, you gotta use all the decimal places. You know, Mr. Park, my calculator only showing me 3. Oh no, Moose Breath, stop. Or maybe showing you, but okay, here. Once you calculate this maximum point, this number is now stored in X. This number is now stored in Y. In fact, okay, you don't believe me, do this. Second quick. TI people. And you other people, I don't know what you gotta do to get to the original screen. Anyway, just press X and then hit the enter button. Doesn't this number come out with all the decimal places? Oh, so then Mr. Park, all I have to type in is this then. Just type in this. Square root of 25 minus x squared. And the calculator just gonna plug in this number with all its decimal places in right there. Yes. Oh, so what is it? 1.082. Try. Just look straight ahead. Pretend you didn't say my name. Because, look, here, let me show you. Some of you don't believe me. Look, watch. What if you did this? Square root of 25 minus 2.887. What if you only use 3 decimal places? Try. Somebody do that. Now, I don't know if it's going to, sometimes you're going to be off in that last decimal place and I have no choice but to take off 1 point. Try it. How long does it take to punch that in? Leon. Oh.
0.0823.
Oh, so it's still correct in the 3rd decimal place. Okay, you got lucky there. No, I'm serious. If you use only 3 decimal places, sometimes you're going to get off in this 3rd decimal place and that's -1. So whenever you use a number in another computation, you have to use all the decimal places. That's why this thing is stored in X, this thing is stored in Y, and then got it made already. Okay, what's the height? What's the height of this cylinder going to be? 2x, so just take this number. In fact, on your calculator, just punch in 2x, and then read what's there. Well, I think I can do this one in my head. 5.7. Oh, but then I don't know the last decimal place, yeah? So what is it? 7, 4, 774. Oh. Okay. Or what if the question was, what is the volume? What is the maximum volume that the cylinder could be? What's the answer? What is the maximum volume? Right there, 302.300. Because Y, look, Y represents the volume. Okay, so all of these problems, same thing. The hardest part for you guys is you gotta write the function. Because if you don't have the function, what are you gonna punch it on your calculator, right? So hopefully these are all familiar because you guys, I'm pretty sure I took some of these right out of your Algebra 2 book. Okay, we're done. This class ends in 6 minutes.